In this video, we'll be looking at electrolysis, in particular, how it works. Now, here's a few things to remember. Cations are the positive ions, whilst anions are negative. And it works under the principle that opposite charges will attract. And then some useful tips. Whenever doing questions on electrolysis, always think about the charge of the particles. And it would be helpful to learn some of your common ions. Right. Now, let's have a look at what electrolysis actually is. And we can understand this by looking at the word itself, where electro means electricity and lysis means to split. And then for your 2-mark definition, it's going to be using electricity to split up ionic compounds. And this is quite a common question at GCSEs. Right. And then along with that, you also need to know your diagram. You can be asked to draw this from scratch and also label. So we'll start off with the power source, and it's really important that we mention that it's DC, direct current. Alongside that, we have the 2 rods, which are known as electrodes, and specifically the negative electrode is a cathode, and the positive one is an anode. And then we have the electrolyte. This is all you will need to label. However, bear in mind there are 2 types of electrolytes. You have your molten, which just means a melted electrolyte, and then aqueous, which means you have something dissolved in water. Now, when drawing this in your exams, you should not actually shade anything in. It should be a really basic diagram, just lines and a few labels. Right, let's have a look at some of the rules involved around electrolysis, starting off with our molten electrolyte rules. Whenever you have a metal cation, this is going to go to the cathode. So cations go to the cathode. When they go there, they'll undergo reduction and they'll make a pure metal. Whereas your non-metal, your anion, will go to the anode, where it undergoes oxidation, so it loses electrons, to make a diatomic non-metal. All that means is you put a little 2 after it. Let's have a look at an example. Now over here we've got sodium chloride, and we know it's molten because it has the L, liquid, for its state. Now in the diagram here we can see the ions. We've got a mixture of sodium ions, which are positive because they're metal, and chloride ions, the negative ones, because they're non-metals. Now following the rules, the metal ions are going to go to the cathode, where they'll be reduced, so they're going to gain electrons to become neutral. And here we've made the neutral pure metals. We've made pure sodium. On the other side, we're going to have the chloride ions going to the anode, where they'll be oxidized and they'll lose electrons. Now, because you make a diatomic product, they're going to join together to make Cl2, chlorine. These are the 2 products we'll make. Now, we'll show how to do half equations in another video and observations that you'd expect to see through electrolysis. For now, we'll work on the rules. So, following the rules for the molten sample, we've got potassium fluoride. We'll identify the ions present, so potassium and fluoride. We have the cation, which will go to the cathode to be reduced, making potassium. On the other side, we're going to have the anion, fluoride, which goes to the anode to be oxidized, making the diatomic version F2, fluorine. Right, here's a few for you to try yourself. Take the next 5 minutes to work through these. Identify the products that are being made. And again, the rules are in the top left to help you. Here are the answers to those questions. Okay, now we've had a look at molten rules. We have to now look at the aqueous, AQ, electrolyte rules. Now these are a little more complex. So starting off, at the cathode, we have to use the reactivity series to help us understand what will be produced. In this case, it's the least reactive cation that will be produced. As for the anode, we're going to follow the following rules in order. Number 1. If you have any group 7 halogens or halide ions, you're going to make the diatomic version. So Cl will make Cl2, F, F2, I2, and so on. And if you haven't got any group 7 anions, then we'll look at rule number 2, where you'll have a sulphate, a carbonate, or a nitrate. And if this is the case, the hydroxide ion that is present will produce oxygen and water. And we will have a look at applying this. So here's our example. And again, we're using sodium chloride, but in this case, we're looking at the aqueous version. Now, remember, because it's aqueous, it's dissolved in water. And water will also undergo electrolysis. It's going to be split up into H plus and OH minus, a hydrogen ion and a hydroxide ion. So all of these are present within the electrolyte. Now, the same rules are going to apply. So we'll identify our positive ions and use our reactivity series to help us understand which is the least reactive. In this case, hydrogen is the least reactive ion. So it's going to be attracted to the cathode. And in this case, you're going to get hydrogen ions, which will be reduced in order to produce hydrogen gas. And we're going to do a similar thing on the anode side, where we'll identify our anions and then follow the rules. So we have a group 7 anion. In this case, it's going to be attracted to the anode and will produce the diatomic version, Cl2. And again, don't worry about the animations here. We'll have a look at the observations of electrolysis in another video. Now, because we've got those remaining ions, they're going to bond together in order to make the resultant product, in this case, sodium hydroxide. Now, like I said, it is a bit more complex, but let's have a look at another example. Magnesium sulphate. Now again, this is where knowing the common ions will be useful. So we'll split this up to make our magnesium ion, our sulphate ion, and remember, because it's aqueous, we're going to have the hydrogen ion and also the hydroxide ion present. Now, the cations are going to be the positive ions, so magnesium and hydrogen. But because hydrogen is the least reactive, that's what's going to be attracted to the cathode. It's going to be reduced in order to make hydrogen, H2. As for the anode, or the anion, we're going to have the sulphate and the hydroxide. And we're going to follow those rules again. So remember, rule number 1, do we have any group 7 elements? In this case, the answer is no. So we go to rule number 2. Do we have any carbonates, sulfates, or nitrates? Well, yes, we've got sulphate. So in this case, hydroxide will be attracted. It's going to go to the anode to be oxidized and make oxygen and water as our products. Now, as long as we remember those rules, which are quite complex, you'll have an easy time with electrolysis. So, here's a few examples to apply for the aqueous electrolytes. Take the next 5 minutes to work through these. And again, the rules are on the top to help you. Here's the answers to those questions. Now, again, bear in mind, because these are all aqueous, they'll always have a hydrogen ion and a hydroxide ion. Right, let's summarize. So, cations always go to the cathode, whilst anions will always go to the anode. And those all-important rules, the molten rules and the aqueous rules, you have to first identify which of the two electrolytes you have. And you will always know this because you'll be told in the question, or they'll give you the state symbols. As long as you follow the rules, the rest clicks into place. Okay, if you have any questions, leave them down below, and I'll get back to you.